Hi, this is Mr. M from your Algebra class. Today's discussion is about real numbers and the history of that real numbers and what is its importance in algebra lessons. So while we're discussing about real numbers, we need to know what is this real numbers, or what are the items we can consider, or what are the types of numbers we can consider as the form of real numbers. So to explain that, I actually need to um, discuss the history of numbers. Okay. um, Actually, these are the things that you may studied in your previous classes or your elementary or middle school classes. So, but just to refresh your memory, I'll explain those items once more. So, the in ancient times, we had actually there was n- no number system was there, but after a particular time when the mankind was um, developed, they started finding numbers, the numerals, just from uh, 1, 2, 3, 4, 5 till 9. So the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, they named it as counting numbers or natural numbers. Natural numbers. So, in ancient time, so we are actually not discussing um, um, more back. We are actually starting our discussion from the counting number point onwards. So, the numbers they started using in ancient time is from 1, 2, 3, 4, 5, 6, 7, 8, and 9. They named it as natural numbers because they used it for counting purpose. They named with another name called counting numbers. Okay, so um, at that time, or little time after, um, an Indian mathematician who added zero with this natural number system. So the number system got bigger, that is starting from zero and the rest of the natural numbers. So they changed the name of this number system as whole number system. So with the natural number system, when zero is added to that set, the name of that system or the set changed into whole number system, whole numbers. Okay, so at that time, the discussion actually developed in different directions. So they thought that, okay, if I'm thinking from a particular point towards to the left or right or forward or backward, so if I'm thinking towards this direction, so the scientist thought that, okay, this is the point. I'm starting from zero. Okay, I'm starting from zero. So why can't I go to the opposite direction? Okay, so they thought like that. As a result of that, a new number system was popped up. That means some set of negative values, 0, and the set of positive values. Okay, so negative values, 0, and set of positive values, they added to the system. So what happened is the number system, the name of the number system changed into integers. So when we started, we had only the positive numbers. I will use a different color pen. Okay, we had only positive numbers, and the Indian scientist had a zero. So the system changed its name into whole numbers. Okay, that's great. And then they added negative numbers also. So the system changed its name into integers. Okay, at that time only the um, discussion started based on fractions. Okay, say for example, um, if if two people is actually trying to share a pizza, two or three people is starting to share a pizza. Okay, then they started thinking, okay, 1, 2, 3, 4 pieces, 4 pieces. Okay, so 1, 2, 3, 4 pieces, and they were asking uh, person 1, person 2, person 3. Okay, so person 1's position portion is this, and this is person 2's portion, this is person 3, and this is the leftover. Okay, so the discussion started because all these three were kind of scientific about people. So the discussions were basically always based on some kind of subject based or subject oriented discussions. So they actually asked a question in between. Okay, I took P1 took 1, P2 took 1, P3 took 1. Okay, so one portion is the leftover. How can we express this leftover in terms of the whole pizza? That was the question. Okay, so uh, everyone actually reached into the same answer, that one portion of the whole pizza, one portion of the whole pizza, which is divided into 4 equal parts, is the leftover. Okay, so 1 out of 4, 1 out of 4 is the leftover. Okay, so now we can explain what is a fraction. A number which is of the form m by n, m by n is called a fraction, and the this top number is called the numerator, and the bottom number is called the denominator. So we have two parts, one is numerator and the other is denominator. And what are the types of fractions that you have already studied in your elementary or middle classes? So I'm actually not going for the discussion. So our discussion is about the number system. Okay, so these kind of numbers, the fractions erased. So the scientists thought that, okay, we have negative numbers 0 and positive numbers. There are numbers in between. Say for example, in between 1 and 2 there are set of numbers, there are fractions, or we can express those fractions in the form of decimals. Okay, then they thought that, okay, we can change the name of the number system. Now we have negative numbers 0, positive numbers, and fractions. Okay, so we have negative numbers 0, positive numbers, and fractions. So they changed the name of the system as rational numbers. Rational numbers. So after this rational number system, we have another system called complex number system. Complex number. Complex number system is kind of a system, or the numbers which are of the form a plus ib. A plus ib is called a complex number. So in a complex number system, we will have a real part and an imaginary part for that particular number. So if the set of numbers together we can call the system together we can call the complex number system. So that is the most recent update for the number system. There are researches going on to find the new number system. So we can stop discussing about the number system. We can study until complex number system. So before we are going to the complex number system, I'm actually trying to discuss until um, rational numbers. Until rational numbers. Okay. So until rational numbers. Okay. So all together, starting from natural numbers, whole numbers, integers, and rational number all together, I can call as real number system. Real number system. All together, I can call as real number system. Okay, so now you know what is a real number system. What are the elements in that real number system? Okay, so now, in this part of algebra, uh, we can try to study um, some some properties of this real numbers properties of real numbers. So basically, um, um, all numbers have the properties that I'm going to explain right now. Okay, so first property is, wait for a moment, my pen is blinking like anything. Okay, so first property is commutative property. Second property is associative property. Third property is distributive property. And fourth is identity. And the fifth one is inverse. I'll explain each one separately. Okay, commutative property. While we are studying about the number system, we need to think about the operations. We know we have four different operations. We have four different operations. 1 second. I'm going to choose a different pen. Okay, green is good. Okay, we have four different operations: addition, subtraction, multiplication, and division. Okay, come on. Okay, so addition, subtraction, multiplication, and division. So um, addition and subtraction is actually kind of related together, or one is the opposite of other, exactly same as multiplication and division. Okay, so while we discuss the properties of a number system or real number system, we will consider only the first two, that means addition and multiplication, the properties for addition and multiplication, because the other two are actually kind of the same but with opposite effect. Okay, so we will consider only addition and multiplication. First, we can consider what is a commutative property. So if we can consider two numbers a and b, commutative property for addition commutative property for addition stating that, oh sorry, commutative property for addition stating that A plus B equal to B plus A. So if you have two different numbers, A and B. Say for example, I'm choosing two numbers 3 and 5. 3 and 5. So the commutative property for addition is 3 plus 5 equal to 5 plus 3. So 3 plus 5, we know that 3 plus 5 is 8 and 5 plus 3 is also 8. So the order is not a matter. That is what commutative property is saying. Okay. Okay. That is commutative property for addition. And now I am going to explain commutative property for multiplication. Commutative property for multiplication is if A and B are two numbers, commutative property for multiplication is A into B. That means A times B, the product of A and B, will be same as B into A. That is the product of B and A. Example, 3 times 7. 3 and 7 are two numbers. So what is 3 times 7? 3 times 7 is 21. I'm multiplying instead of 3 times 7. If it is 7 times 3, 7 times 3 also 21. So what is commutative property basically explains is the order is not an issue for these two operations. Okay, addition and multiplication. That is what commutative property is saying. That is A plus B equal to B plus A, or A times B equal to B times A. That is what commutative property explaining. And next is associative property. Associative property, we can consider three numbers, A, B, and C. So those three numbers, A, B, C, is the numbers that we are considering. Associative property for addition explains that A plus B plus C is same as A plus B plus C. See, the parenthesis or the brackets are actually playing a big role in this explanation. A plus B plus C. See, what I'm stressing is B plus C. That means you need to operate B and C together, then operate it with A. So, say for example, if I'm considering three numbers, 3, 5, and 7. So, what is associative property for addition stating is 3 plus 5 plus 7. So, because we have a parenthesis here, we need to operate that first. 5 plus 7 is 12. 12 plus 3 is 15. Okay, that's done. Now, this is 15. Okay, now we are actually trying to operate it in a different way. So, I am actually operating 3 and 5 together first and then 7. So 3 plus 5 is 8. 8 plus 7, that is 15. Okay, so you can see this answer on the left and the right, 15 and 15. So what does it mean? That means the order is not making any difference in these two operations, addition and multiplication also. Say for example, for multiplication, we can choose a different color. For multiplication, okay, for multiplication, the same numbers, 3 times 5 times 7 is 3 times 5 times 7 is what? 5 times 7 is 35. Okay, 3 times 35. 3 times 35 is what? 5 times 3 is 15. Remainder is 1. 3 times 3 is 9. 9 times 1, 9 plus 1 is 10. So 105. So 105 is actually the product. Okay, we can check whether this will satisfy the associative property. What is associative property for multiplication? A times B times C is equal to A times B times C. So we can first try 3 times 5, 3 times 5, and times 7. 3 times 5 is what? 3 times 5 is 15. 15 times 7. 15 times 7 is also 105. So what does it mean? That means for associative property also explains the order is not a matter for addition and multiplication. So those are very important rules that you can use in your real number study. Okay, so and in your higher class, if you're choosing something um, related to math for your higher studies, definitely you may find that these rules are important. So don't forget um, don't forget to understand these rules. I'm not asking you to by heart, but try to understand. Okay, so now we can go ahead with distributive property. So what is the distributive property? Distributive property. So the term itself explains what it is. It is distributing. Say for example, if A, B and C are three numbers, A, B, C are three numbers. So A times B plus C. A times B plus C is, what you need to do is you need to distribute the external item to all the terms inside the parenthesis. So A times B and A times C. Okay. A has relation to B and A has relation to C. So A times B is AB. Then don't forget to put the sign in between these two numbers. That means the sign in between those two numbers is plus. So you have to put that sign here to connect the products. So A times B plus A times C is AC. So your answer is AB plus AC. Say for example, I'll show you an example. Um, 7 times 8 plus 5. 7 times 8 plus 5. So basically what we need to do is um, um, if we are not using the distributive property, what we will do is we will add these two numbers, then multiply with the external numbers or the 7. But just to show this distributive property, what I am trying to do is I will multiply these two numbers first. 7 times 8 is 56 plus 7 times 5 is 35. Okay, what is 56 plus 35? 56 plus 35. 6 plus 5 is 11. Left over is 1. And 5 plus 3 is 8. 8 plus 1 is 9. So it is 91. Okay, so that is 91. We can check whether this is correct or not. See, 8 plus 5 is 13. 13 times 7 is also 91. So this answer is correct. So 91. So we are actually not thinking whether this answer is right or not. I'm actually trying to explain how you can operate this operation, how you can operate this bracket. Okay, you can call this in a different with a different name if the operation is just like this. If x plus y times a plus b, x plus y times a plus b, if the question is like that, I will do this question like this. I will operate the second bracket with the first element. So x times, we will put an into sign here, x times a plus b. Then I'll put the plus sign in between this. Whatever be the sign in between this, you have to put it there. So because here it is plus, I'll put the plus sign in between and take the second number, that is y times a plus b. Okay, so now you can operate this bracket just x times x and x times b. Okay, so xa plus xb plus y times a, that is ya, and y times b, that is yb. See, this is the answer. And see, for example, I am actually trying to do this in a different way. Instead of splitting this first bracket, I am actually multiplying directly. So that is x plus y times a plus b. So multiply these two together. X times a is xa. Okay. Then put this sign plus x times b is xb. Then, so the numbers actually finished in the second bracket. Come back to the first bracket. What is the next item in the first bracket? It is a plus sign. Put that here. Then y times a is ya. Then plus y times b is yb. See, both answers are same. Okay, so xa plus xb plus ya plus yb. Here also xa plus xb plus ya plus yb. So so it is actually not making any issue with the answers. So that is what is called a distributive property. Now we have very important item, identity and inverse. These are the very important items that you need to understand for your present course and the future course. So identity is existing for both addition and multiplication. Identity is existing for addition and multiplication. Okay, so for addition, the identity is 0, because if we add 0, with any numbers, it is actually not making any changes. So 0 plus 1, what is that? It is 1. 0 plus 100, it is 100. Okay, 0 plus negative 1, that is negative 1. So identity explains 0. 0 is the additive identity. We will call it as additive identity. Identity for addition is 0. So keep it in mind, identity for addition is 0. So what is actually that concept explaining? If any number or some item or anything is not making any change to a system, we can call that item as an identity. Okay, so that is what is called identity for addition. So similarly, there is a number. Because we are discussing about numbers, I am actually only concentrating in numbers, and I am not going outside the box. So for multiplication, what number will keep the product as it is? So uh, everyone knows that it is 1. It is 1. So 1 is the number. Say for example, 1 times 1000. 1 times 1000, it is 1000. 1 times a million, that is a million. 1 times a billion, a billion. 1 times a trillion, it is trillion. So it is keeping as it is. It is not making any change for the second number that we are multiplying with 1. So that is why we are calling 1 as the multiplicative identity and 0 as the additive identity. So 1 and 0 is acting as multiplicative identity and additive identity respectively. Okay, now we can think about the final thing called inverse of a number. Okay, so inverse means, say for example, let me explain this inverse concept with numbers. Say for example, I am having a number 5. I'm asking what is the inverse of the additive inverse. There are two types of inverses. One is additive inverse and multiplicative inverse, because there are two different kinds of identities existing. That is the reason the two inverses are. Okay, so my question is, what is the additive inverse of 5? So okay, so 5. Okay, so let me think. Okay, which number I need to add here to get, because I'm asking the question additive inverse, my answer should be the additive identity. Okay, what is the additive identity? It is 0. So the number that I'm going to add here is called the additive inverse of this number. So if I need to get the answer 0, I need to add the number which is just opposite of the first number. So that will be -5. So 5 plus -5 is 0. This 0 represents the additive identity. Okay, so additive identity. So 5 plus -5 is 0. So this -5 is called the additive inverse of this number 5. Okay, so that is what explain additive inverse. Now we can look into multiplicative inverse. Multiplicative inverse, keep it in mind while discussing about the inverse, you should have an idea about identity. If you are discussing about additive inverse, so what need to pop up in your mind is the identity. Okay, so when you're discussing about the additive, so the multiplicative inverse, so um, so what need to pop up in your mind is the multiplicative identity. What is the multiplicative identity? It is 1. So let me ask a question. What is the multiplicative inverse of 5? Great question. Okay, because this is a multiplicative inverse, we need to multiply something with this number 5 to give the answer. What is the multiplicative identity? It is 1, to give the answer 1. So what number I need to multiply with 5 to get the answer 1? So keep it in mind, if the answer for a multiplication, the product is 1, the terms, the items, or the numbers that you are multiplying together will be reciprocals to each other. Okay, or in other words, we can say that inverses to each other. So you know what is the reciprocal of 5? Okay, it is 1 over 5. Okay, so 1 over 5. So 5 times 1 over 5 is 1. So that we can call this 1 over 5 as the inverse of 5, because when I am multiplying 5 and 1 over 5 got cancelled. So my answer is 1. So that I can say that 1 is the multiplicative inverse of uh, of of this number 5. So that explains the concept of inverse. Okay, now we can conclude this whole explanation by drawing a picture. Okay, so we can start with the red. Okay, we can start with the red. Okay, so we started with natural numbers. We started with natural numbers. Then we added what? We added 0, so it becomes whole number. Okay, then we added what? We added negative numbers, so it becomes integers. Okay, not finished. Then we added rational numbers, sorry, fractions. So we called it as rational numbers. Notating with Q. Okay, this is what is called the whole system. The whole set is together called as a real number system. Real number system. So this is actually explaining what is a real number system. So for getting the continuous videos, please subscribe this channel, and thank you.